Alright, we're now going to do a t-test for the significance of the slope. Now, remember that it's sort of pointless doing both the t-test for the significance of the correlation, little r, and the t-test for the significance of the slope, because they both tell you the same information, whether or not the relationship, or the correlation, which is the same thing really, between the x and y variable is significant or not. Okay, so this should give us the same result. The only reason that I'm doing it on the same data is to again reiterate the point that there is no difference between talking about a correlation between two variables x and y and a linear regression between two variables x and y. Same result as the t-test on R. Alright, so a lot of this will be, if not the same, very, very similar. So the null hypothesis will be that the true slope is 0. That means that x does not explain the y variable. Alternatively, the true slope is not 0. That means that x does explain the y. We have an x and y scale that, and if you have a straight line relationship, but that straight line happens to have a slope of 0, in other words, parallel to the x-axis, that means that you can move the x value all you like and the y doesn't move, it stays put. Okay, so if the slope is 0, then x does not explain y. Okay, and a similar sort of concept was as what we used with the correlation test. Degrees of freedom will be identical as the correlation test. N minus 2, 7 minus 2 is 5. We will nearly always use the standard alpha of 5% from now on. So we have a t with 5 and a two-tailed test, so 2.5% each tail, and a critical value again of 2.571. Alright, and then from there we can do our decision rule. And it'll be nearly identical to the one for the t-test and the correlation. So if t-calc is between plus or minus 2.571, there is an insignificant relationship instead of correlation, but basically they're synonyms. Insignificant relationship between our two variables, growth rate and return on equity. Alternatively, if t-calc is not between critical values of plus or minus 2.571, in other words, around the tail somewhere, far enough away from 0, there is a significant relationship between our two variables, growth rate and the return on inequity. Alright, now we're ready for our T-calc, but let's run through the formulas. Actually, we'll first put down the final formula. T-calc is beta hat 1, the estimated slope, divided by its standard deviation, or what is usually called standard error. So beta hat is called the coefficient of x, and divide that by what is called standard error. Alright, sometimes instead of T-calc this is called a T-ratio. It's a ratio of these two items. Alright, S of beta hat 1 is a concept that we've talked about before but not calculated or given a formula for. It's S of E, the standard deviation of the errors, divided by the square root of the sum of squares of x. S of E, standard deviation of the errors, is the square root of the variance of the errors being the error sum of squares divided by the n minus 2 degrees of freedom. Right? Said in the last class or so that every estimated variance is the appropriate appropriate sum of squares divided by the appropriate degrees of freedom. So under the square root sign we have this variance, take the square root and we get the standard deviation. So this is the standard deviation of the errors. The errors being the distance between the points and the line. Alright, and then the error sum of squares. Sum of squares of y, syy, minus beta hat 1 times the sum of squares of xy. And the result there must be greater than or equal to 0. Mostly greater than 0. Alright, so those are all the formulas. Alright, so let's now do those calculations. So the error sum of squares, again, sum of squares of y minus beta hat 1 times sum of squares of xy. Alright, let's find those numbers. Alright, sum of squares of y, 47.36. Minus the beta hat 1, which is a 0.2995, times the sum of squares of xy, is xy 84.26. Remember the result here must be positive, and the result is 22.12. Alright, next step is the standard deviation of the errors, S of E, square root of the error sum of squares which we've just calculated, divided by the degrees of freedom. So that's square root of 22.12 divided by the 7 minus 2 or 5 degrees of freedom. Alright, and that's easy to do. There's 2.104. Okay, next step is the item called the standard error, S of beta hat 1. That's S of E divided by the square root of the sum of squares of x. So that's a 2.104 divided by the square root the sum of squares of x, and the sum of squares of x. That's 281.3. Okay, and the answer to that is 0.1254. then finally we can go to our t-calc, which is the estimated slope divided by its standard error, and that is 0.2995 divided by 0.1254, and the result is 2.388, which, if you go back and check, is the same result, exactly the same result as the t-calc in the what we'll call the R test, the correlation test. Alright, which it should be, but sometimes it's different because of rounding error. And so we'll have exactly the same decision, except we'll change one word, that is, we'll change the word correlation to relationship. So, since t-calc is 2.388, and since that is between our critical values of plus or minus 2.571, there is an insignificant relationship between our two variables. Alright, the growth rate of those particular companies and the return on equity. Alright, and that's the end of the t-test on the slope.